internet users is kept private and personal. Example includes sovereign, Uport, Civic, and Blockstack. Money transactions. As discussed in chapter 4, there are 4 different types of tokens: currency security, utility, or asset tokens. Currency tokens, meaning cryptocurrencies, are used to make financial transactions, and the most well-known is, of course, Bitcoin. Others include Zcash, Bitcoin Cash, or Monero. Wallets. Of course, all those cryptocurrencies need to be kept somewhere. Wallets are the bank accounts of the crypto world. You can have hot wallets connected to the internet or cold wallets disconnected from the internet. Examples include MyEtherWallet, Jax, Exodus, or Trezor. Exchanges. Like with stocks in companies, tokens need to be exchanged. So there is a range of centralized and decentralized exchanges. Centralized exchanges have the risk of being hacked, which is not possible with a decentralized exchange. Examples of centralized exchanges include Bitfinex, Bitstamp, Coinbase, or Kraken. Examples of decentralized exchanges include Aux, Bisq, BitShares, or EtherDelta. Industry applications. Every industry can use DLT to improve collaboration, enable provenance, speed up transaction settlements, or enable transparency. Energy consumption, the 6th challenge, concerns the energy consumption of decentralized networks. Although there are a variety of consensus mechanisms, the proof of work consensus mechanism is still most used. POW requires solving complicated puzzles, which uses vast amounts of energy. It is estimated that the POW consensus mechanism in the Bitcoin blockchain currently consumes 66.7 terawatt hours per year, which is comparable to the total energy consumption of the Czech Republic, a country of 10.6 million people. Fortunately, new blockchains might use different consensus mechanisms, which requires significantly less energy. In recent years, the number of available consensus algorithms has exploded. It seems that every blockchain is developing its own consensus mechanism. Here is an overview of what is out there. Delegated proof of stake. Same as proof of stake, but the number of tokens you own determines who gets to vote and elect witnesses. Least proof of stake. Users can develop their own tokens, which they can use to improve their security on their server farms. Proof of elapsed time. Similar to a proof of work algorithm, but the difference is that this algorithm focuses more on the duration of the computation. Simplified Byzantine fault tolerance. There is one validator that can bundle multiple transactions to create a new block. Delegated Byzantine fault tolerance. This consensus mechanism uses game theory to verify blocks among professional miners. Directed acyclic graphs, or DAG. They do not have a blockchain structure, but often require users to validate 2 transactions if they wish to add 1 transaction. This verification can use a simplified proof of work algorithm. Proof of activity. A combination of proof of work and proof of stake to make sure that tokens offered as a reward are on time. Proof of importance. The more you send and receive transactions on the blockchain, the more tokens you will receive. Proof of capacity. Used specially for decentralized storage as it utilizes the availability and capacity of storage space on a user's drive. Proof of burn. Miners have to show proof that they burn tokens, which means sending them to verifiable, unspendable addresses. Proof of weight. Similar to proof of stake, but it depends on various other variables called weights, which basically means combining various features of various consensus algorithms. More when we discuss the consensus later in the detailed session. Resilience, irreversibility, quantum computing, and lack of standards These are also challenges related to data on blockchain. Resilience and irreversibility are two key attributes of blockchains. Once data or transactions are appended and accepted by a network, they can no longer be changed. However, only authenticity can be ensured through a blockchain, not reliability and accuracy. If bad data are offered correctly, they will end up on a blockchain. Likewise, if a document contains false information but is offered right, it will end up on a blockchain. Theoretically, data on a blockchain will be there indefinitely, but the development of quantum computing means the cryptography used today might not be secure in the near future. Therefore, data governance will only increase in importance within organizations adopting blockchain. Poor execution of smart contracts and hence poor automated decision making can subsequently result in tremendous problems. Although blockchain reduces costs and increases efficiencies due to a shared ledger and smart contracts, lack of standards could cause a counter effect. Standards are important for networks to deal with information systems and they can help to align an industry. However, obtaining global industry standards for new IT is difficult and it could take some time before organizations have a shared global blockchain standard on which the International Organization for Standardization is currently working. Final thoughts on blockchain is a promising technology. Blockchain, particularly when used in concert with other technologies, offers organizations an opportunity to rethink their internal and external processes, remove inefficiencies, improve transparency and provenance, and build a better organization overall. However, it faces numerous challenges that could affect its adoption across organizations. However, significantly more research is required to overcome the considerable governance and technological challenges involved therein. Scalability and lack of speed, talent, and standards could slow down both its implementation and the development of new blockchain applications, negatively affecting the development of new organizational forms such as decentralized autonomous organizations. Yet, despite these challenges, there have been dozens of new applications in almost every industry that apply distributed ledger technologies and are already benefit from these fundamental technology.